All right, go to the Buoyancy Archimedes Principle worksheet. And again, from those, according to Archimedes' principle, an object placed in a fluid is buoyed up by a force equal to the weight of the displaced fluid. I'll go through several examples with you here, and then have you work on the last three on the back of this paper. All right, for sinking objects that will sink, you have an object, and here in this case it weighs 150 units. Well, that's it. It's holding on the spring scale in the air. If I stick that object into water, it now only weighs 100. So there's some buoyancy force acting on that object. Well, you can see the amount of water that got displaced is 50 units. And that's where that apparent weight loss had gone. From going from 150 to 100, the 50 is now the water that got displaced. So let's put the numbers into this table. So weight of the object in the air, well, it weighed 150. Holding it on the spring scale in the air, it weighed 150 units. The weight of the object in the water went down to 100. So now it's, the scale says only 100. So it weighs less, apparently weighs less. The apparent weight loss is 50. It went from 150 to 100. It seems to weigh less than by 50. So gravity now is saying that it is 100. And the buoyancy is 50. So it says when an object sinks in water, okay, make sure you read this carefully. When it sinks in water, gravity is greater than the buoyancy. It's pushing it. Gravity's pulling down more than it can push up against. The buoyancy can push up against it, going to the bottom. Now, for objects that float, use diagram below to provide the missing information. There's this block that seems to be floating on the water, and it weighs 50. Well, at the same time, the water that it displaced is also 50. 50-50, right? So the weight of the object in the air was 50. Well, what's the weight of the displaced water? It's also 50. Gravity at the moment, this object's floating there. Gravity on that thing is 0. There's no gravity, no apparent gravity. The buoyancy is 50, equal to the mass. So when an object floats in water, gravity is going to be less than the buoyancy. It's not pulling down strong enough. The buoyancy is stronger than the gravity. All right, so for these, I'll give you some numbers and some scenarios here. And usually I always put the numbers in the table, decide if it's sinking or floating. I'll do the first one with you. The weight in the air is the number of the object is 250. It apparently, and weight in water is 0. If it weighs 0 while it's in water, the apparent loss is the total amount, 250. Okay. The gravity currently is 0. The buoyancy is this much that we have over here in this side, on the side cam, 250. This object is floating. So please try the other two problems and take a picture of those and submit those for homework. And then the last thing you have to do is the homework that's on the buoyancy and the submarines, history of submarines. A couple questions. You can submit those by picture, or if you'd like to, you can also do it through Google Classroom.